answer, a squared. Picking up from our example from Friday. 941, done. Kill the puppy, even though it's not up there. You have to think about it like we did with algebra when you guys were doing silly mistakes like with FOILing. Remember when we were doing things like, what's x plus 4 squared? And some of you guys thought it was x squared plus 16, and I said, poor little puppy's dead. Right? What's the way to make sure you do this right every time? That's the way I'm teaching my Algebra 1 9th grade people that don't really like math right now. I say, forget the shortcut. Rewrite it. I'm telling them that you guys mess up on it so that they have more motivation to get right what you can. Just kidding, you can, as long as you think of rewriting it as well. What is x plus 4 times x plus 4? That's correct, right? Why am I showing you that example? Don't think of a squared, think of a times a. What? A times a, okay. So I have a and I have, alright, fine, another a. Dun, 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 dun. What are the orders of each?
3 by 1.
1 by 3. Oops. And a 1 by 3. No big deal, let's go. Can we go?
Nope.
Nope. Why? Well, if we tried, yeah, how would you guys describe it? The insides don't match, but why is that a problem? What are we trying to do? We can't go down if there's no one to match, right? 3 could go with 3, but who's 2 going to go with? Nobody. Who's 1 going to go with? Nobody. So multiplication doesn't work. We have to keep in mind cross down. But if it could work, could we multiply? And the answer would be yes. So, just so that, because we're on a new day, and we haven't done, you guys probably haven't done in a while, in case you did it over the weekend, unless you did it over the weekend. Let's do another example. What if I said, find a squared 4, a is equal to 2, 3, negative 1, 5. Ready, set, go. Is it possible? A 2 by 2 with a 2 by 2. Okay. Hey, what would make squaring a matrix possible? What kind of matrix would it have to be? A square matrix. A 3 by 3, a 4 by 4, a 5 by 5. I kept it nice. I'm going to freeze it. You guys go. Square that puppy. Huh? You're welcome. Yes, happy Monday. How you guys doing? Tired? A long weekend. Not long. Half weekend. Short weekend. Go as slow as you need to until you get the hang of it. If you try to go too fast, it may very well fail. Dun, 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 dun. Oh, what's happening?
Because you have 2
I'm showing you guys just my very first fact. 2 times 2 plus 3 times negative 1. That's to make this guy. Two times 3 and 3 times 5 would make 6 times 15. We keep on going all day in different colors. It's going to get way more confusing. Negative 1 times 2 and 5 times negative 1 will make negative 2 minus 5. And then negative 1 times 3 and 5 times 5 makes negative 3 plus 25. Work out all the facts, done, done, done. Now, be honest, it's okay. How many of you guys made a mental math or a multiplication addition error somewhere? Ooh, you're still finishing it and just using another look. It's very common to make addition or multiplication mistakes if you go too fast. So make sure you get the hang of it first. If you needed to, could you technically write out the whole 2 times 2 plus 3 times negative 1 for the first one? Yeah, you could. You could if you want to be super careful. Then go to 4 minus 3, then go to 1. Same thing here. If you need to write it out, you could do your 2 times 3 plus 3 times 5 to get your 6 plus 15. You can do an in-between step if you need to, just to make sure that you're on the right side, on the right path, if you're taking the right direction, using the right method. Any questions that you guys can ask? Okay. Yeah, let's keep going then. It takes a while to get used to, though. No shame in that, but that was why you were supposed to be working on homework this weekend. Maybe not finishing it for today, but working on it. So the biggest thing we need to get used to is that A times B is not necessarily B times A. Multiplication for matrices is not commutative. Addition is, multiplication's not. Addition is, multiplication's not. But a few things that make sense are still true. Even though the top one is not true, the bottom 4 are true. But be careful. Be careful. Because if you notice, this multiplication down here below is very particular. If A comes before B, it comes before C. A has to come before B, has to come before C. You can't go switching the order. You can't go doing CB or BA instead of AB. No switching the order at all. We can technically switch the order in number 2. We can say C plus B instead of B plus C. We can switch the order of the addition, but we cannot switch the order of multiplication. We cannot do BA or CA. Same thing in number 3. Distributing a different way is still totally legal as long as A and B come first. You just have to maintain that order. And then number 4 just has to do with the scalar. No big deal. Scalar can be multiplied after you multiply the matrices. Scalar can be multiplied first, then multiply the matrices, or scalar can be multiplied by the second and then multiply the matrices. But once again, the order is important. We have to maintain the order. Not that you guys have to memorize these formulas, but just to let you know which ones can still apply that makes sense, and which one is drastically different than we used to. Long story short, off this page, the one thing I need you guys to write down, properties of matrix multiplication, A times B is not necessarily B times A. Out of all of them, that is the most important. And as you guys work, let's see, how much more do we have? Ooh, a couple more. We got this. We'll finish 8-2 for sure, for sure. We might just barely be able to start 8-3. Tomorrow, juniors, yes, I know you're gone. Don't worry, I'm tracking. But hopefully you can still have 8-2 ready for me for Wednesday, especially since Mrs. Choi is going with you, so she can't really give you history homework for tomorrow night. Hopefully. So make sure my math homework is due for Wednesday.
Are we still going to be doing stuff tomorrow?
Hold on, music, we'll work. Sound good? Nice. Go team. Alright, let's keep going. Super special property of the identity matrix, although we kind of already talked about it. Identity. Additive identity for numbers is 0. Anything plus 0 is itself. Multiplicative identity for numbers is 1. Anything times 1 is itself. Multiplicative identity for matrices is the identity matrix. Any matrix times the identity is itself. The identity times any matrix is itself as well. Probably bigger cut off somehow. I don't really know how. So let me fix that while you guys are working. That should be a 0. That should be a 1. I think that's a negative 1. And not just, the identity is not just special because any matrix multiplied by it will turn out to be the same thing, but it's also special because it doesn't matter the order that you multiply by the matrix. If the identity goes first or if the identity goes second, the result will be the same. The result will be the same. However, in order to have an identity matrix, doesn't the beginning matrix have to be square? Since the identity matrix is a square matrix, this property only holds for other square matrices, if that makes sense. So if you have a 3 by 3, use a 3 by 3 identity matrix. If you have a 2 by 2, use a 2 by 2 identity matrix. Remember, identity matrix just says leading diagonal of 1s and the rest are 0s. As you guys are writing, let me prove why that works. 3 times 1 is 3, negative 2 times 0 is 0, 5 times 0 is 0. The first element would be 3. 3 times 0 is 0, negative 2 times 1 is negative 2, 5 times 0 is 0. Second element, negative 2. 3 times 0 is 0, negative 2 times 0 is 0, 5 times 1 is 5. You keep on going, but I think you guys might have the idea. The zeros get rid of all the other elements, and the only ones that stay in multiplication are the ones that were there to begin with in each of the corresponding spaces, entries, places. Whatever sounds better to you. Same thing if we go the other way. 1 times 3 is 3, but then zeros are going to cancel out the rest. So we just have 3. 1 times negative 2 is negative 2, but the zeros are going to cancel out the rest. Just negative 2. 1 times 5 is 5. Zeros will cancel out the rest. 5. As you notice, as we keep on going, the exact same property. Hold. Okay, so any matrix times the identity is itself. The identity times any matrix is itself as long as A is a square matrix. You guys got the important stuff? Sort of, kind of, maybe? Let's keep going.
A times B equals times A.
Now, I don't know if necessarily you need to write this whole shebang. Long story short, what's going on? Matrix multiplication can show or signify or symbolize the coefficients of a system of equations times the variables equaling the constants. In a sense, which is really weird, in a sense we're factoring out the variables, which is very weird factoring because it's matrix multiplication factoring. When a matrix has gotten multiplied, each of the entries has been multiplied by corresponding, or I should say each of the entries in a row has been multiplied by corresponding entries in a column. So it's definitely a lot harder for our brains to grasp how to go forwards, how to factor, but maybe it's a little bit easier once we see the end result. A1, A2, A3 would get multiplied by x1, x2, x3. Or you can think of it as x, y, z, if that's better. It doesn't have to be x of 1, x of 2, x of 3. X, y, z suffices. The A1, A2, A3 would match up with their corresponding variables. Similarly for the second row, A21, A22, A23 would match up with their corresponding variables with the second, first with first, second with second, third with third. Now why is that so useful? We're not going to really see until the next section. But long story short, if we can say or put any system of equations into this form, where you have the coefficients, or a matrix of the coefficients, with a matrix of the variables equaling the constants. Maybe there's another way to solve a system without row reducing. Maybe there's another way to solve a system without row reducing. Maybe it has something to do with if we have A times X equaling B. If we learn in the next section how to undo A. Whoa. What did I just write down? Undoing A. If I can find the inverse matrix and multiply it in the correct order on the left of A, and what I do on one side, I do in the exact same order on the other side. It has to be in the same order. A inverse on the left. If I can figure out who A inverse is in the next section, then maybe I can get the identity times. And if I can get the identity times the variables, I can just say identity times the variables are the variables. Here's another way to solve a system of equations. But it still begs the question, who is A inverse? And for right now, we have to say, we don't know yet. He's still coming. That was just a foreshadowing of what's to come. But once again, we can call this an augmented matrix. It's a little bit different in its augmentation. But the same idea of splitting apart the coefficients from the variables and then setting the constants off to the side. A couple more seconds to you guys.
Well, what's the inverse of A?
That's in section 8.3. Dun dun dun. Gotta wait.
Dang.
But I was showing you the usefulness or the purpose of being able to write a system of equations in that way. But the nifty thing is that your calculators actually can do inverse matrices with the hit of a button. It's a button that usually means reciprocal for numbers, but it actually means inverse for matrices. But we'll see that tomorrow. Alright, you guys ready? Set and go. Ooh, life just got exciting. Word problem with matrices. Scene! Set the scene. What's going on?
Milk!
Dairy Mart. It's milk.
Dairy Mart. There's milk. Does anybody actually know what a Dairy Mart is?
No.
It's a place that pretty well, it's a place that pretty much sells milk. It's like more like Colorado and in like the South and stuff. I don't know if they're in California. Are they like just next door to California? Never been there.
What is it?
Just next door. They usually have like 7-Eleven kind of have like waters and like sodas and stuff, but pretty much they just have that. Okay, at a local Dairy Mart. Stop judging. The numbers of gallons of skim milk, 2% milk, and whole milk sold over the weekend are stink. They didn't label the rows or columns, did they? We have to figure out which is which. Focus. The selling prices in dollars per gallon and the profits in dollars per gallon for the 3 types of milk are sold by the Dairy Mart are represented by B. So hold on, wait. B might be a little easier. Question, kiddos. What do the rows and columns of B represent if we have 3 types of milk? Okay, we could do that. Maybe different sizes. So we're still trying to figure out this part, right? But I did hear a few of you guys answering what this is. How do you know what's going on in the rows? There's 3 types of milk. If we have 3 rows, we gotta fill it in with a 3, right? So I'm guessing they did it in the same order. So we'll say skim goes first. Then we'll say 2% goes second. And we'll say whole goes last. Because of the prices? No. Because that's the order they gave it to us. Ideally, they should have labeled this themselves, but they're trying to see if we can interpret a matrix. So we have skim, we have 2% and whole. Now we need to figure out why on earth are there 2 different columns. Luke, what do you see? Selling price and the profits. Good. They identified for us. But it could have been different things, like different sizes, etc., except they told us. Selling price and profit. Which one makes sense to be the smaller, even though we usually go in the order they give it to us no matter what? Yeah. Why would profit be smaller than selling price? Yeah. Selling price is having to cover all sorts of different costs, right? Profit is the what you get to take from it. So selling price. Okay, so wait, we figured out matrix B all right. Who have we still not figured out? What do you guys think? How do we label the rows or the columns? Which one is no? Columns? Loco there? Or is Loco here?
I say columns and then
Why?
the rows because like when we're taking because we have to do the cross down. So when you're taking the cross and you can go down that and then we can also say that each row is each day of the week. I mean of the weekend.
Skim 2% in whole, because when we multiply across, skim is going to get multiplied by his price. 2% is going to get multiplied by his price. Whole is going to get multiplied by his price. We have to have them match, right? For cross down. And then, wait a minute, hold on, Sean. How is the days of the weekend? I don't get it.
Well, because it's a weekend, so we can infer that we can have a Friday, Saturday.
When does the weekend start? Friday. Good. Friday. Believe me, for businesses, the weekend starts Friday, right? A for kids taking off school, and B for people going out on Friday nights. All did what I was supposed to do. Okay, so. Wait, what are they asking us for A? Compute A times B. Hey, graphing calculators, go! Show me that you can multiply two matrices using a graphing calculator. Compute A times B. We still have to interpret, but let's go ahead and just compute.
Okay, let's follow.
Plug in A, plug in B, do
Let's
the
do this
multiplication,
together.
make sure you use your calculator.
It's gonna go in
Calculator,
A1. 40.
We have a 3 by 3 and a 3 by 2.
That's A1. A2. Yeah. And then keep going. Yes.
We get to use our calculator.
The more rows you have, the more work it is.
We get to use our calculator. Yes, we had 3 by 3 for
It's
A.
just like,
You could call B A and A B, but that'd be confusing.
good. No, I don't. Yeah, I don't really do this one.
Somebody beat me, right? You know what I'm doing? I'm gonna get my matrix A, I'm gonna get my matrix B. How did you do the multiplication? What'd you do? How? Just times?
I'll do
Go.
some things.
No. Oh, that's right. We can get their names, right? So we're gonna get matrix A, and we're gonna literally say times, and we're gonna go get matrix B. Except you guys actually have the matrix in the matrix in letter B, right? In the menu. Mine's not gonna work because nobody's there. Ah, okay. However, yours should have. And what did you guys end up getting for A times B, starting with the first row, first column?
571.8. 206.6. 798.9.
Why am I putting zeros after them?
Because it's
Currency.
I think it's monies. Keep going.
288.8. 936. 337.8.
37? Because they're monies. What kind of monies? Wait, we gotta interpret the results.
Dollars.
Dollars?
$10.
Isn't this still gonna be skim 2% and whole?
And it's still gonna be selling cost.
Oh. It's actually quite a bit.
Or is it-
Floor, but it will stay the same.
Think about it. Something's wrong. Something's wrong that I'm writing. But you're adding stuff up when you multiply, right?
Dang,
That's how you
that's some bad business.
Sean's saying it should be by day. How come? And I agree with him. I'm changing it to this is Friday, this is Saturday, this is Sunday. Why?
because you're taking
The skim selling plus the 2% selling plus the whole selling. And what are we doing for this first one? Adding them all together. So we're figuring out the selling profits for Friday and then the selling totals from Friday and the profit totals from Friday from all of the milks put together or added together. Does that make sense? What's another way of looking at it? Hey kiddos,
You have a business and you're making $200 a day.
That stinks.
don't we say rows by columns when we talk about matrices, right? And what wasn't this days and wasn't this milks? Can I say milks? Probably not. And then this one was 3 milks by 2 totals, profits, monies. We'll just say monies. Do these match? Yes. What is the order of the result? Oh, we could have figured out days and money that way. Just by thinking about the insides have to match and then the outsides give the order. Luke, does that make sense?
Or
Oh.
how many weeks in a year?
52? Approximately. Depends-ish. Yay, we're done. Homework 49, 8.2 due tomorrow. Technically on Wednesday. Although I expect it to be done on Wednesday, ready to check on Wednesday because I have the answers all ready to go for Wednesday.
You do?
What are we counting the days?
They make that 700 weeks, so I make 36 days.
Hopefully they're selling something else besides though.
Yeah, I hope so.
Oh, it seems like a nice startup.
Yeah. You have to
Besides the
work
whole
for like
having to get the count.
25 years to buy a house.
I hope he's investing
Yeah.
It's expensive.
Maybe you can
But
expand
then
it
comes
to
the
ice
age-old
cream.
like moral dilemma of we could sell other things that would maybe make more money, but then it might not be.
Just add ice cream. They just want
Oh, sure. Add ice cream with it. And yogurt.
Cheese.
And sour cream and cheese. Could be a creamery. Give these with
You
better.
don't like the word creamy?
No, creamery.
Creamery.
I don't like it. I don't like it.
I don't like it.
Just
I'm
kidding.
gonna say it right now.
That's just me.
Let's stop it.
I think.
But I don't feel like. My dad is so tasting my sister. She's in Australia for the last month. She already spent like $5,000. She's my sister.
She was like, all the songs. Isn't it actually three things?
She's having the time of her life though.
It's so Oh, Avalor or something like that?
Yeah. She's literally like she never gets it.
RICO.
That's no fun. What's a more fun one? You guys are Precalc.
See whoever would listen to this recording. I hope you enjoy, man.
What are my first two examples supposed to show? Something about a matrix? Nope. What are my first two examples show? How do I solve? I use the inverse. I heard someone say ln. That was perfect. Why? How do I undo e to the 3x? How do I undo the e to the? I need the inverse, right? I need the inverse. Remember, inverses undo, like ln and e, and I end up with 3x equals, let's see if you can follow, x squared times ln of 2. Wait, what? ln properties, he pops down. Then I can technically divide both sides by x squared. And I can multiply by x and then divide. My final answer, x equals 3 over ln of 2. Why do we need inverses? To undo stuff, right? How would you undo number 2? Remember the big old 2?
Yeah.
We end up with 5x squared is equal to 2 cubed is 8. Don't go there, put 6. X is equal to plus or minus square root of 8 fifths.
Yes.
Why do we need inverses? To undo stuff. So what are we going to be undoing on Wednesday? Because tomorrow's a work day. Looks fun.
Why do they finally get the bells to ring at like third period?
Because they're cool like that.
Okay, you know.
Yay. There we go.
I guys see